Research is formalized curiosity, it is poking and prying with a purpose. So said Zora Neale Hurston. Number systems are thrilling subject of research, and perhaps the simplest and the most significant one. Mean poking and prying numbers for specific ends or just for the love of play. But what are the ground rules for cooking number systems and how to ensure it serves any purpose? Change is the only constant, and by default it means continuous change, whatever be the pace of change. It is the law of the nature, that is, science. Here are examples of continuous change in the natural world. Rocks wither away over time. Continents are adrift at an imperceptible speed. Every atom is a hub of motion. Weather conditions are hardly the same even for a minute. Change is also the law of the man-made world, which follows the scientific laws. For example, even buildings continuously wither, change, from outside, chemically, biologically, sun rays, etc., and structurally, such as continuously changing compressive load on pillars. Here are examples of continuous change from the man-made world. Continuous change in the tension in the steel rope of a moving lift. It is a complex collective of stress, such as abrasion, flexure, tension, and compression. Change in temperature of the tires of a moving vehicle. The road pavement and subgrade constantly decompose, deform, and degrade. Have you realized to know the world, the simplest way is to know how it changes? Change is majorly continuous, slow-est or fast-est, perceptible or not. For example, the laboratory measured half-life of radium-223 is approximately 11.4 days. Here, the change would be seen as a series of continuous changes in atomic structure due to the change in the quantity of infinitesimal subatomic particles. Another example is how a particle of water in a river undergoes continuous change in its motion. The direction and speed varies with gradient and obstructions over the land it flows on. Naturally, the first step is to know what change is. That is, what to look for as the change. Change is how everything evolves for good or bad. It is fundamental. Mathematically, quantifiable change is the change. To the extent, scientific measurability dictates what is quantifiable, and to what level of confidence measurement is a big deal in change. Broadly, mathematically relevant change is physical or chemical. Physical also includes immaterial things, for example, economics, pure mathematics, research, even space and time changes, that is, relativity. Quantitative biological changes are physical or chemical, for example, BP, amylase levels in blood, trend in birth rate, etc. Continuous change is mathematically interesting rather than discrete. Algebra is adequate for discrete change. Continuous is also the truth of nature. Most change are multidimensional. For example, in motion's change of position is also change in direction, speed, acceleration, jerk, etc. Importantly, in an infinitesimal instant or scale, everything is constant. Time period affects quantity of change, that is, time accumulates or aggregates change. Change is relative to, changes in a thing can be seen together with changes in other things. Every change has intrinsic effects, change that has the thing itself as reference. For example, something moving away 10 meters from its initial position. But there are also extrinsic references in change, and these are very common. Most changes make more sense, are more insightful, when viewed with change in something else. For example, change in an electric motor's speed is more directly and immediately impacted by the voltage applied to it. Most things are subsystems of a larger system and also a system in their own right. In such situations, every change makes more sense in relations to some change in the larger system or one of their own subsystems. For example, change in interest rates affects savings and investments in the larger economy. It is as common a need to induce desired changes in something, and such changes are mostly through changing something else to get the desired changes. For example, change in the perimeter of a circle is through changes in its radius length. No less, there are limits to change in things and conditions, because change in one affects something else too. The limits are of two kinds, intrinsic or extrinsic. The extrinsic limits to change are about how something cannot change, in its pace of change, or quantum of change, in a way that it ill affects the working of something else. For example, acceleration in a vehicle is linked to jerks felt by the passengers. Thus, there is often a limit to the acceleration of most vehicles. In radium-223 decay, the change is in the quantity of radium-223, and that is with respect to time. For a particle in a river, change in its horizontal position is with respect to time. But change in its vertical position can be with respect to height too. The change in the rate of chemical reactions could be studied with respect to concentration of the reactants or with respect to temperature of the reactant solution. The change in plant growth could be measured with respect to varying soil nutrient levels or irrigation besides time. Change has to be specifically defined, measured, quantified. The multidimensionality of change, intrinsic manifestations of change, and extrinsic relationships of change must first be delineated, defined, stated for change to be recognized. Largely, continuous changes have to be measured. Except when the change quantum is in discrete amounts, it could be counted too in such cases. Most interestingly, changes could be quantified without measuring them. That is, measuring them mathematically or what is called analytically. Pertinently, the physical or the direct measurement of change is simple algebra. Analytical measurement is what the domain of mathematics, such as calculus, is. Of course, analytical measures can never be wholly non-physical measure. They derive, that is, compute from the physically measurable primary changes. Calculus is an analytical measure of continuous change. Calculus uses the rate of change of something to derive many kinds of measures of change. Thank you. With us, you will master all the mathematics you need. Be good to you, not just others.